students out there and hacking away, and I think some of you saw earlier in the sessions. But that's just one module. So, for us, we believe in multi-network, and so I don't know how many people are involved really in the Internet of Things, but the typical way you would connect a device, as I mentioned initially, is using cellular. And so cellular is good because it's high bandwidth, it's high speed, 4G. The downside is expensive because you've got Qualcomm license fees to pay, which make 4G so prohibitively expensive for a lot of IoT devices. And there's a huge drain on battery. So great applications if you're powered into the mains and you've got a screen and you're doing advertising, then you're going to have 4G. But the fact is, a lot of these devices, which are 20 billion devices in the market, they're never going to live and need those prices or speed. So everything we do is powered off a battery, and we offer multi-network. So the Wi-Fi, which is the first, how many people have bought a low pi, or I understand there's a few, yeah, there's a couple here, 3, okay. Right. So this is the first one, Wi-Fi and Bluetooth, so you can do multi-network, basically many home or business applications. The Wi-Fi, we now have 1 kilometer range on Wi-Fi, so that opens up applications in the city. And again, the benefit here is Wi-Fi can be kind of free. The low pi, we start adding the LoRa chip. So I'm not sure how many people know what LoRa is. LP1, low power wide area network. And so this is a different style of transmission versus a traditional cellular in the sense that it's what we call a high bandwidth of radio spectrum, and it can travel a lot further than cellular. And it also has different benefits versus cellular, which means it can penetrate into concrete. And so if you've got a lot of your devices which are in basements, like some vending machines deep into buildings, or lifts where you need to press a button and say, I'm stuck, you need to get through quite a thick barrier of stuff to get to that device. So LoRa has been a technology that really has come to life, I'd say, in early 2015, late 2014. Something that was invented in the late 80s in France. Semtech took over the technology, they make it available on the chip, we put it on there. The next one, so the benefit I should say of LoRa is, just like the university here, you can get a gateway, and you can put that in your building, and you can become what's called a service provider. And so you can open up your gateway to other people who have built devices using the LoRa technology. And then you can decide if you want to charge or not. So you'll see in a lot of these communities, like the Things Network in the Netherlands, or just private cities coming to life with these technologies. A big community play, a big developer play, and so there's big benefits there because you can actually get technology for free. The SciPi uses a technology called Sigfox, so there we substitute the LoRa with what we call Sigfox. And Sigfox is kind of the same as LoRa, except that it's an ultra narrowband radio spectrum, and so it's supposed to travel even further, but a lot more directional than LoRa. And so that rollout is being done as a network, as if you're seeing so Sigfox roll out what they call Sigfox network operators. They control the entire network, and it's closed. So against the LoRa, which is open, Sigfox is closed, but the benefit then is you get SLAs. So if your device is business critical, you're going to need an SLA. If you want consistency in the upstream of data or the availability of the network, you're going to pay a bit more. And so that's where you'll see in Sigfox for businesses that say, mine is business critical, I need an SLA, I need it up 24/7, versus the community play, which could be connected to this wall, and I've just unconnected it to do the Hoover, and then I'm back in my DDoS mode. All right, the next thing we'll bring out is cellular, because cellular has got a new competitor to Sigfox LoRa. So what you see is the network operators, so the Vodafones, the Telefonicas of this world, the AT&Ts and Verizons, who for years have had end-to-end devices on their networks. and for years have had a real issue with having their devices on the network. And the reason they have an issue is because, unlike you and me that have a mobile phone, and we have this usage, and if you've ever got a daughter like mine, then you always pay more money to the operators because she's on YouTube every day and off the Wi-Fi range. And so they love that because humans are very unpredictable and they bring them a lot of money. A device typically sends very little data, and so they never can make that much money out of the device other than what you're contracted for. And yet you're using the towers, and then you cause network storms if you've got all your iPads connecting to the network at the same time. And the spike on what's called a HLR in the network environment, you fry the systems. And so some of the networks have gone down, and if you've ever heard of Telenor up in Scandinavia, they had their network off for 2 days because of the network's what's called a storm of cellular connectivity happening at the same time. And because then each device saying, hey, I want to connect, they re-authenticate. And so each device then sends 100 re-authentication. So these network operators are keen to take this traffic off their normal network operators, and they've brought up this technology, or they're pushing the technology called LTE-M. And so LTE-M will be a competitor to LoRa and Sigfox. There's 2 types. It's dependent on the data speed. So Pycom, our next device that we'll launch and make available in February 2017, I've got the first prototype here, has got LoRa, Sigfox, Wi-Fi, Bluetooth on this side, and here you can see the nano SIM card, and here the cellular device. And so what we're trying to do at Pycom is to push the boundary and make all of these networks available on low-cost devices. Pycom, so we do Python. I don't know how many people program in Python, so we do it. There you go. So MicroPython is a version of Python, and that's what powers the, let's say, it's the high-level language we use for people to program the devices. It's open source. We build the libraries, and now we're going to have all of our thousands of developers being able to contribute to the source code and do things that you would expect. All right, I just probably want to, I don't want to, yes, that's probably how you feel. Okay, let me just show this one. Hi. I was asked earlier, could you just give an overview of the 3 technologies? And so here they are, sitting side by side. So if any of you are looking to our devices and you need connectivity, we've talked about LoRa, the TTN, so things network and personal. There you make it free. There's low cost because it's shared by the community. You have LoRa commercial. In the previous session, we talked about some of the operators who are bringing out LoRa commercial. So there you're starting to get SLAs, but obviously you have to pay. And so then that's a consideration you're going to have to think about. Sigfox is a closed network, although it's an open source chip. And there again, you start getting SLAs, and costs can be medium, a bit like a LoRa commercial network. And there I've spoken about LT-M stroke narrowband IoT, which is the new cellular. So that's it. Thank you very much for your time, and obviously questions later.
Right, now, get tweeting, get hashtagging, and all that sort of stuff, get the debate going. We're going to do audience Q&A with a few sort of live questions I've just been looking at now. Grab a seat. James, where are you? Are you still here? Yes, you are. Dave. Just grab these seats. Yeah. Bring them to the front. Guys at the back, can you just kind of position us? Now we're going to do the mics. So basically, I'm mic'd up, you're mic'd up, so I've got to go there. So, yeah, it's just as long as you're within range, and it's mic, no mic, mic, no mic. There we go. Right. Does any, just to sort of take a step back, do you guys get the kind of the concept and the point of an LP WAN, just a low power wide area network? and the fact that it's optimized for things rather than people, right? These devices, they're optimized for people-to-thing communication, as are laptops, computers, and so on. But increasingly, like I said to you before, the internet isn't really about that anymore. It's about things that don't have human-to-machine interfaces. There's no screen, no keyboard. It's a little device that could be in the middle of a field. And what it's doing is pinging data back and forth, reporting on the nitrogen levels in the soil, or detecting pollution or disease in the crops. No human required, it's just being pinged up. And so you're talking about little teeny packets of data, not these great big